In this question that follows, we'll be solving a half-life practice problem. Enjoy. The question tells us that the half-life of iodine-131, which is a radioactive isotope of iodine, it's 8.05 days. If an iodine solution is initially 0.1 mole per decimeter cube, or the molarity 0.1, what will the concentration be after 60 days? And here we're told the radioactive decay is a first order process. So what we do is we write out what we have from that question. We're told that the half-life is 8.05 days. We're told the initial concentration of iodine in that solution is 0.1. So and we're also told the number of days it's left to decompose as 60 days. So what we first do is we find out how many half-lives do we have in this 60 days. That's how many times will this solution be able to decompose to half time of its value, to half of its initial value. And how we get the number of half-lives is by this formula. You use the number of days you leave the solution to decompose and divide by what it takes, how many days it takes to get the half-life, which is 8.04. So 60 days divided by 8.04 days will give us the number of half-lives, n, as 7.46. So to find out what remains after it has gone through 7.46 half-lives is we use half raised to the power of n, which is the number of half-lives, the number of times it has divided its initial concentration by half, and then we multiply by the initial concentration. So the remainder is going to be half raised to the power of 7.46, which is the number of half-lives, times the initial quantity, 0.1. And that's going to give us 5.669 times 10 raised to the power minus 4 m left. So the solution is left with 5.669 times 10 raised to the power minus 4 molar